First, let's talk about the data types in Swift. Swift has two kinds of data, constants and variables. So if I do let x equal to 8, this is a constant and it's an integer. Since it's a constant, I cannot change its value to something else. This will not compile. However, if I do var y equal to 8, this is a variable integer, and I can change its value to something else. Swift is a static typed language, and the type is inferred from the value that is assigned to. So y is an integer. Even though y is a variable, I cannot assign a string to it because its type is an integer and it cannot be automatically changed to a string. If you want, you can define multiple constants and variables in one line. For example, I can have var a equal to 9, b equal to 8.0, and c equal to hello. And again, the type of this data are inferred from the value they have. So a is an integer, b is a double, and c is a string. There are times that the type of the data cannot be inferred. For example, var AA, I have a variable, but I didn't assign any value to it, so Swift has no idea what type it is. In that case, I need to annotate its type with a type name. For example, int. This is called type annotation. Constant is a little bit different. If I do let bb and I don't assign any value to it, even though I annotate a type as an int, it still won't compile because a constant always needs to be initialized. So let's say it's equal to 7. So in most of the time, a constant need not to be type annotated. And as a general rule, if you know that the data is not going to change, it is always preferred to use constant rather than variables. Not only because using constant can allow Swift to do better optimization of your code, but also it makes your code more readable. So far, I have been using alphabetic letters to construct the names of the constants and the variables, but you don't have to. As a matter of fact, you can use any of the Unicode character to construct names. For example, I can do let and a Chinese character hao as the name of the constant, and its value is good. And I can also define a variable which is a dog head, and its value is dog head. So you can virtually use any characters from any language to construct the names of the constants and variables. You probably have noticed that none of the statements I have here ended with a semicolon. In Swift, the ending semicolon is optional. You can add it if you like, but you don't have to. The only time you have to add a semicolon is when you have multiple statements in one line. For example, I have a equal to 8 and b equal to 0.9. Now I have two statements, so I have to have a semicolon to separate them. Now let's talk more about the data types. So far we have run into the types of integer. Let I int equal to 9. Int is assigned integer. It can be either 32-bit integer or 64-bit integer. Depends on the hardware platform you are running your code at. If you're running your code on the iPhone 5, then it will be a 32-bit. If you're running on the iPhone 5S, it will be a 64-bit. And you can see the max value of int by doing int.max. And as you see, my int is a 64-bit integer. int.min is a very small number. Another type is called UInt, which is an unsigned integer. And just like the int, it can be either 32-bit or 64-bit. And the max value of UInt is a very large number, and the min value of UInt is 0. Another type is a Boolean, and it can be either true or false. In language like C and C++, a non-zero number can be automatically converted to a Boolean, but that is not the case for Swift. So if I do BL equal to 8, this will not compile. We also have the data type of double, for example 8.9. And double is always 64-bit, no matter what kind of hardware platform you are using. We also have the type of float, and float is always 32-bit. And last but not least, we have the string. So these are the basic data types in Swift: int, uint, bool, double, float, string. If you look at these values, 7, 9, 0.9, doghead, these are neither variables nor constants. They are just a bunch of values. They are called literals. And the literals can be represented in different format. And let's talk about that. First, look at the integer literals. We already know that integer literals can be represented in decimal format, like 17. We can also represent that in octal format. For example, 0017. This is an octal number of 17, which is a decimal number of 15. We can also use hexadecimal format. Var hex equal to 0x17, which is equal to a decimal number of 23. And of course, it can be represented in a binary format, being equal to 0b1011110000. Now let's look at floating point literals. Floating point literals, we already know it can be represented in the form like 1.2, but it can also be represented in the format of 12e3. So E3 basically means 10 to the power of 3. So this is equivalent to 12 times of 10 to the power of 3. So the result is 12,000. If we do FL equal to 12e minus 3, then the result is 0.012. And we can also represent a floating point in a hexadecimal format. For example, FL equal to 0x12 P2, P3. P3 means 2 to the power of 3. So this is equivalent of 0x12 times of 8. Both integer literals and floating point literals can include underscore in the number to increase the readability of the number. For example, hex equal to 0x1234 underscore ABCD. This is equivalent to the number that doesn't have the underscore in it. And floating point value FL equal to 0.2345 underscore 789. So again, the underscore has no effect on the value of the variable. And we already know a string literal is just a string. Unlike in C and C++, in Swift, the numbers of different type cannot operate with each other. So for example, I do let sum equal to hex plus fl. This will not compile because hex is an integer and fl is a floating point. And in order to do this kind of operation, I have to convert one of the number into the same type as the other. So in this example, I'm converting fl into an integer. However, whenever you're converting a floating point to an integer, you need to watch out for the information loss. For example, int 2.7, I'm converting a floating point of 2.7 to an integer, and the result is 2. The 0.7 is rounded off. Int negative 2.3, the result is negative 2. That's all for now. Feel free to subscribe to my channel and see you next time.